Okay, all I want to do with this video is to show you the different kind of notation you might see when doing line integrals. For example, we're going to get an integral that looks like this. It looks like integral c xy dx minus y squared dy, and they're calling it a line integral. They'll give us a curve that say they want the line segment from 0, 0 to 2, 6. But how in the world is that the line integral? Well, this actually looks like a dot product if you look at it. This actually looks like two vectors being dotted, xy and minus y squared being dotted with dx, dy. This is actually going to wind up being our vector field right here. You're plugging in a point and you're getting a vector. This actually comes from a notation before we take the limit, delta x, delta y, and the idea is if we have a curve and we have a point from here to here, yes, that we're calling this delta r out here, but that's just delta xi plus delta yj. So this really is dr vector, this really is f of xy, so it really is a line integral. Meanwhile, writing it this way allows you to do it a little bit differently. I think it's actually a little easier to calculate, but then you have to think hard about why it's work. But meanwhile, let me show you what we need to do. We still have to find parametric equations. So I'm going to write down that x equals 0 and y equals 2. And then we add multiples of the displacement vector. So this should be 2t. This should be 6t, like this. Now what does that do for me? Well, you can do this. Ready? You can just start writing stuff out. X is just 2t. Y is just 2 plus 6t. Now what is dx? Well, remember when you took substitution, you'd say, there's my substitution, now let's write down dx. Well, what you were doing, you take the derivative with respect to t of both sides and then clear the denominators, and you just get something like dx equals 2 dt. And that's what we're going to put right here instead of dx. And I put a big fat minus. Y squared is just going to be 2 plus 6t squared. I want dy. What's dy? dy, again, doing this like you did your substitutions, that's just going to be 60t. Like this. I can just put 60t like this. Let's see here. When we write down this kind of parameterization, remember that when t is 0, we're at the starting point. When t equals 1, we're at the ending point. So this just goes from 0 to 1. And we just get our integral. And let me just write it out a little bit so that it looks a little bit cleaner. And we'll leave it at that. So I'm going to go from 0 to 1. I'm going to write down 2t. I'm going to write down 2 plus 6t. I can write down 2. I'll just bring out a dt at the very end. And then minus 2 plus 6t quantity squared times 6 dt. And we get a nice easy Calc 1 integral. And we never actually did bring in vectors or the vector field. This is wonderful for actually calculating something. But it's horrible for understanding why it's work. So I probably usually like to prefer the other one, but if someone hands us this kind of problem, we should now know how to do it.